So now let's look at some practice. Let's look at this problem. When aluminum metal reacts with air, it produces a white powdery compound called aluminum oxide. So see if you can balance the chemical equation that relates to this chemical reaction. Pause the slide and see how far you can get. Well, the first thing we want to remember is that when something reacts in air, it is going to be reacting with oxygen. Air contains nitrogen and nitrogen is not very reactive at all. So it's going to be reacting with our oxygen. So here we have aluminum as a metal or an element, reacting with oxygen also as an element to form aluminum oxide. Now, how would you know that this is the formula of aluminum oxide? Well, aluminum is a type 1 metal, meaning that it always has a positive 3 charge, and oxide always has a negative 2. So we find the least common denominator, 6 for both of those, and we get 6 by having, 2 aluminums and 3 oxides. If I have 2 aluminums, I have a total charge of plus 6, and if I have 3 oxides, I have a total charge of negative 6. So aluminum oxide has to be AlO2O3. So here's where we begin. Aluminum plus oxygen goes to aluminum oxide. Now we know that aluminum as a metal is a solid, oxygen is a gas, and it tells us we get a powdery compound, so it must be a solid. Also, if we remember that ionic compounds are always solid, so this has to be solid. It's ionic because it's made from a metal and a nonmetal. So let's look at balancing. If we balance our aluminum and put a 2 here, and we look at our oxygen, it's a little tricky here. What I'm looking for is the least common denominator for 2 and 3, and that's 6. So what I want is I want 3 oxygens and 2 in front of here. So now I have 6 oxygens, but that changed my aluminum, so I'm going to have to go back here and change that to 4. So here's my balanced equation. I have a coefficient of 4 for aluminums, 3 times 2 is 6 oxygen, 2 times 2 is 4 aluminums, 2 times 3 is 6 oxygens. So notice I originally put 2 for my aluminum and realized that that wasn't going to work. That's part of the process when you're balancing equations. You've got to constantly reevaluate and change your coefficients as a new coefficient may change the number of elements that you've already balanced. Here's practice number 2. Acetic acid reacts with the metal aluminum to make aqueous aluminum acetate and gaseous hydrogen. Now, acids are always going to be aqueous. That's what we're going to assume. And also metals are always going to be solid except for mercury, which is a liquid. So pause the lecture and see if you can write out the skeletal equation, which is the basic formula for each one of these chemicals involved in the chemical reaction. So here is our chemical reaction. Let me get this out so we can see it. Okay, here is aluminum metal. Here is acetic acid. How would we know that? Well, it's an oxyacid because it doesn't begin with hydro. And ic came from ate, which is acetate. This is the formula for acetate. And acetate has a negative 1, so we have 1 hydrogen. So here's acetic acid, and it forms aluminum acetate. Well, how do we know what the formula for aluminum acetate is? Well, aluminum is always plus 3, and acetate is negative 1. So when we bring down our charges as subscripts, this is what we get. And if we look at the charges, they do cancel out. I have 1 aluminum for a total charge of positive 3. And then I have 3 acetates for a total charge of -3. So our total charge cancels out. And then we're also told that gaseous hydrogen is formed. And hydrogen is part of our SU10 or Brinklehop, or no fear, chlorine boy is here. Here's our hydrogen, H2. So these are the correct formulas. Now let's look at how to balance them. Because I have acetate on both sides of the arrow, I can look at balancing acetate rather than breaking down the carbon and hydrogen and oxygen. I have 2 acetates over here. I'm going to put 2 acetates right there. No, I have 3, so I'm going to put 3 right there. Now when I do that, I change my hydrogens. This hydrogen right here is what forms this hydrogen. How did I know that? Well, this hydrogen here is part of my acetate. So I have 3, and now I just have 2 over here. That's not going to work. I'm going to look for the least common denominator between 3 and 2, and that's going to be 6. So I'm going to make this 6. I need 6 acetates. Put a 2 there to get 6 acetates, and then a 3 there. And then I'm going to go back and look at my aluminum. I need a 2. So let's make this so there we go. Okay, when I look at my coefficients, they have no common factor besides 1. These hydrogens here from my acid form my hydrogen gas. I have 6 acetates. I have 2 times 3, 6 acetates. I have 2 aluminums and 2 aluminums. So here's my balanced equation right here. Here's one last one. Here we have the combustion of ethanol. Ethyl alcohol is the alcohol in alcoholic beverages. And here's the reaction for its combustion. You would be expected to know how to write this if you were given this formula. If you were told combustion of ethyl alcohol, you would know that it would be reacting with oxygen, and anything that has carbon and hydrogen in it that burns forms carbon dioxide and water. They always form in the gaseous state because so much heat is released. So pause the slide and see if you can balance this equation. I'm going to start with my oxygen last because it is in 2 compounds over here. And if I try and balance it first, it's going to mess up my carbon and hydrogen. I want to balance my carbon and hydrogen and do my oxygen last, since it's a free element over here and I can add whatever coefficient I want. I have 2 carbons, so I'll put a 2 there. I have 6 hydrogens, so I'll put a 3 there. Now my carbons and my hydrogens are balanced. 3 times 2 is 6, 5 plus 1 is 6. Now let's look at my oxygen. 2 times 2 is 4, plus 3 times 1 is 3, 4 plus 3 is 7. I have 7. Well, I have 1 here, and if I make this 3, then I'll have 6. 6 plus 1 is 7. So that's how we balance this reaction. See if you can balance this one. Combustion of liquid butane in a lighter. We start out balancing our carbon with a 4, then our hydrogen with a 5. I now have 4 carbons and 10 hydrogens on each side. When I look at my oxygen, 4 times 2 is 8. 8 plus 5 is 13. So here, 6.5 times 2 is 13. Well, I don't want to have a fraction, so I'm going to multiply every coefficient by 2. So this will be 2. This will be 13, this will be 8, and this will be 10. Here's my balanced equation.